Hello, welcome. I'm so excited to be here at the DUC factory in the Beaujolais region near Lyon, France. And we're about to get a tour of the DUC factory where they make a line of propellers for various kinds of aircraft. And we're going to go take a peek inside and see how it's made. Come on with me, we'll learn more about it.
So we are right now in the new building, new from 2 months, something like that.
Oh, congratulations.
Yeah. So it was mainly to improve our strengths in the office team. So mainly on the engineering team that is going to grow up and already grew up. Like we've got 2 new engineers that are arriving at the end of the month. So it's in order to answer to the market needs. We've got a lot of demands from eVTOL and VTOL companies, more and more, like a lot of big companies and new companies that want to develop their own VTOL to enter the market, but also for our main market, that is the ultralight market that we want to develop. The fact that we want to go on the certified market, we need to have a bigger strength on the engineering part. Bit empty at this time of the year because it's on the middle of the holidays in France.
Holidays, yeah.
But we've got a team of 6 engineering for this part. Also the commercial part and the reception just on this side. We can go directly to the production if you want.
Excellent.
We're gonna start with the first part, so going from the start of the production to the end and the final product.
Okay.
Will make more sense. So this is the cutting room. It's where we are cutting the carbon fiber. So we receive it in rolls like that we are stocking in the cold room. Okay. And after, when it's ready to be cut, we just bring it here, put it on the table just behind. And so we've got 2 tables with 2 axis cutting table, cutting with a blade, not laser, not water, with a blade, in order to respect all the procedures that we need to have for the propeller and aeronautical products. So if we
one more time, so.
if we use water, it's not. I mean, we are not allowed to use water for this kind of product. And if we use laser, it's going to burn the surface of the carbon.
So the integrity of the carbon fiber.
Yeah, and we cut with a blade.
Cut with a blade.
Directly. So we cut the carbon. We've got several layers of carbon that we're going to put on top of each other. So it's always the same size for the fiber, you see. And after we are following a pattern in order to cross the fiber to make it more strength. So we cross the fiber of carbon following a certain pattern for each blade. And we create what we call mattress of carbon. So we got 2 mattress for 1 blade. And after we're going to put it on a foam to create the final blade. I'm going to show you after.
Excellent.
This part.
Wow.
So this is a room where we are balancing and finishing the rotor blades. So mainly for helicopters or VTOL, eVTOL. This one is for VTOL, for example. And these are rotor for helicopters.
Okay.
So yeah, you can see the leading edge part here. Mm-hmm. It's the same process that we use for the blades. There is no extra thickness. There is a tab on each blade, and also salmon here. It's the last part of the rotor. What we can do if we want to rebalance the blade, we can remove this part and add some weight inside in order to balance the rotor perfectly.
Wow.
And after we just close it back. After you.
Thank you.
So we've got the company aircraft just here. Bonjour. So yeah, mainly the Tiger III was designed for 912. As I told you, in order to for a bit like heavier aircraft, in order for us to generate more thrust and to get a better performance in takeoff, climbing, and also it's to say that for the landing performance also, it's working very good. We've got like 20% better performance in landing with this propeller than with the one we used before. So there is a big difference for 912 going from, for example, the Swirl, which is our typical propeller, to the Tiger III. Inconel. Yes, that's it.
Inconella.
So yeah.
That's the metal.
Yeah, leading edge. So it's the one we are using for most of the tests also. So that's why it's very useful to get an aircraft here just to test the new product. We, as I told you, in like 2 to 3 months we can develop the new product and directly test it on the aircraft. That's quite easy to get the feedback.
Huh? It's like you need a sling highway.
Maybe the next one. Yeah, that's why. So what we call Tiger III is the shape of the blade.
Got it.
So we can always change the size, the diameter. We
so
can
this
go
is
from
shorter
2 blade to 5 blades. So this one is shorter than yours.
Okay, that's why.
But what we call Tiger III is the shape. So what we call Tiger III is when we are going to use a mold to cook the blade, it's going to be a Tiger III. And after, it can be a 2 blade, a 3 blade, 4 blade, 5 blade, whatever. We can cut the diameter to make it bigger or I mean to make it smaller. And yeah, that's it.
Excellent. What kind of an aircraft is this?
Viper from Tomark. It's just after the molding. Not the finishing part.
Right.
Still need to be done. Just after the molding.
And what if you didn't know you can choose the color of your...
Yep. And our foam.
Oh. Now I am thoroughly confused. Okay.
Special foam that we put inside. Then we are putting two, as I told you, the 2 mattresses of carbon, which are, each mattress is additional layer of carbon, putting like on top of each other.
I was saying matrix, so you've got... So this is inside my blade.
This is inside your blade.
Ah, okay. Got it.
Because if it was only carbon, it wouldn't be as light as it is.
Got it.
This is mainly where we do the finishing parts when the hub, spinner and blades come out of the mold after the curing. We just need to remove the extra part of carbon. It's just tiny part of carbon that just move out of the mold. So you just need to squish it out. And I mean, so this is for your type of blade, for example. Yes, this is a Tiger one inside. All the pressure on this side and also the mold, which is in 4 parts, the top, bottom, and the two sides, is gonna keep all the carbon inside.
So you said the top and the bottom of the sides. Does it actually push from the sides?
No, it's not pushing from the side, but the goal is to get the perfect lock on the side. But it's pushing on the blade roots.
That didn't make sense. I didn't see the side push, so that's why I asked. Okay, great. Wow.
Yeah, that's it. So this is a process for which we've got a patent, which is a carbon forged patent. So it's made so we put the mattress of carbon inside the hydraulic presses. Then it's gonna close it.
Great. So now, if I understand correctly, you guys patented this forged carbon fiber process. So please tell us more about that.
Yeah, exactly. So it was patented by Vincent, the CEO and founder of the company. So it's a forged carbon process, that's the name of it. So it's a process for the manufacturing of the hub that are, we use 2 half hub in order to stock the blades of the propeller. So we put the carbon mattress inside the hydraulic press. Then after there is a teeth on the outside that are going to cut all the edges of the hub, of the half hub. And during the curing at a certain temperature level, you will have the holing that are going to be from the inside of the hydraulic presses. So you're going to have these holes and all the little one on the outside and on the inside that are going to be manufactured at the same time as the curing process. So it makes it way more resistance. And to go a bit further on our production presses, it's all designed internally by the design office, the engineering office, all designed internally, all the different parts. Then after we just order the part and make it done by other partnership, other company that are on the region. And when we receive all the parts, we just assemble the hydraulic presses from the ground, just here. We assemble it. And so we also own the knowledge of our tooling, if I can say that, and of our hydraulic presses. So it's easy for us to create a new presses for a new blade, for example, and in order to increase the production, just creating 1 and 2 presses in 1 or 2 months, for example.
Great, great. So not just for the production, but for the development.
Exactly.
You can speed up the development.
Exactly.
One of the things that is popular about your product is the ease of service and how easy it is to assemble and install. Do you want to tell us a little bit more about that?
Yeah, sure. Either it is ground adjustable or in-flight adjustable, we can send the propeller fully disassembled to the customer in the package. So it's reduced delivery cost. And for ground adjustable, you use a tool to adjust the pitch, like a bubble tool just to adjust the pitch manually. It's very easy to do. And for the in-flight adjustable, if you just by following the manual, you can do it. It takes like less than 30 minutes to 45 minutes just to assemble the propeller and put it together on the aircraft. So it's quite easy to mount, to install, quite easy also to maintain, for sure. And for all the TBO period that we've got, the customer just disassemble the propeller very easily, send it back to us, and after, so it's just lowering down all the cost of maintenance on the product.
And what is the TBO on, say, the Flash 3 or the Type?
So on the in-flight adjustable propeller, it's 5 years or 1,500 hours, and on ground adjustable, it's 5 years or 2,000 hours.
Okay, great.
Yeah. So you can see different type of blades we do with different color, different shape, and all the hydraulic presses behind. It's all managed and followed by the ERP, as I told you. So all the time of curing is followed here, with who is in charge, how many blades, for how long, and yeah, basically all the presses got numbers, name, and it's all followed inside. We use some tools like this in order to help us to drop each blade. We've got the foam.
So you mean...
So the dropping process is when we put the 2 mattresses on the foam in order to create the final product, which is a blade. So we use a foam just here, which is the middle of the blade. Then we use intrado and extrado mattress, put it together. We close it with a blade roots, aluminum one. And we add the inconel, which are just here, for each, so the leading edge part. And after, name of the blade, the logo, different colors available, and the tip. That's it.
That's where we store the parts.
Of in-flight adjustable system that we can use in order to deal with all the customer needs. So we've got hydraulic system using a hydraulic governor, and we've got the hybrid system. We call it hybrid, so it's we are using a small electric motor engine that we are putting directly on the engine, and that is activating a carbon or aluminum rod to push inside the hub in order to manage the pitch change.
Okay.
And the last one is a full electric one that we use. So we put the small engine here, and that is activating aluminum rod that goes through here in order to go through the hub and to manage the pitch. So it's pushing, so it's and the engine is activating
it's
with
mechanical, not hydraulic.
Yeah, it's a hybrid with electric and mechanical.
Electric and mechanical hybrid versus a hydraulic.
Exactly.
Oh, so okay.
On 915, 916, we use hydraulic. It's the best. It's made for that. So.
Okay, but there is a new governor.
Electrical governor from.
But it's still actuating hydraulically.
Yep.
Okay.
Exactly. Not the same.
Okay, different.
Yep.
Different hybrid.
Different.
Okay.
The propeller. So balancing each blade with the other, and yeah, we are putting it inside the box in order to go directly to the customer. Same in carbon, and we use also glass fiber. So mainly for the spinner, it's carbon fiber, glass fiber, and another layer of carbon fiber.
This is for people that want to paint it, huh?
Exactly, yeah. I mean, we are doing it on carbon color and white color. We can also paint it. We've got someone that is painting for us, like just like 5 minutes away. Thank you so much for such a wonderful day here at the DUC factory. And what do you call this region? Beaujolais. The Beaujolais region. Say it much more eloquently than I do, of course. Thank you so much for your time and for giving us a tour of this incredible process and factory. It's very exciting to visit you and to learn about just how nimble you guys are and flexible and innovative. Sure, we try. And to see the process up close and personal. Thank you so much for the access and to meet the rest of your leadership team. It's been an absolute pleasure getting to know you. Thank you so much again for your time. Thank you for visiting. It was a real pleasure to show you the facilities and how we are working. It's always a great pleasure to show to the customer like how the product is made, and you are more than welcome whenever you want. Thank you so much. Thank you. Great.